Very good morning, students. Am I audible? Can anyone write in the chat box? Okay, thank you. Okay, so myself, Prabhat Behra, your chemistry teacher. We are going to start the first class in our class 12 curriculum. So, as you know, I am teaching the organic chemistry for you. In organic chemistry, what are the chapters to be discussed under class 12 curriculum? Haloalkane and haloarine, then alcohol, ether, phenol, aldehyde, and ketone, carboxylic acids, and its derivatives, amine, then biomolecules. So, we'll see in our NCERT curriculum, in the NCERT book, these two chapters are given under single chapter. That means aldehyde ketone and carboxylic acid and the derivative gote chapter dechi. Emi dekhile these are two different chapters. So in total, according to the NCERT curriculum, in total it is 5 chapters, but it is 6 chapters. Okay. So before going to haloalkane and haloarine, we should revise the organic basic concepts because towards the end, very less number of students were present. So आमे starting रो किसी organic रो concept revision करिवा, जोड़ा 11th class है थिला, and that is also interrelated to all the chapters. Then we'll proceed to class 12 syllabus. Okay, students. Now, yes. Okay. So in organic chemistry, the class 11 syllabus, first देखिबा, what about the bond cleavage? What are the bond cleavage? Means how the bond dissociation takes place in organic compounds. In organic compound, it is the covalent bond. So covalent bond is formed as a result of sharing of electron. If the bond is to be dissociated, then the sharing of electron, the distribution can be there. The distribution can be homolytically or can be heterolytically. So, bond cleavage is possible in two different ways. One is homolytic cleavage, another is heterolytic cleavage. Quickly, I revise kar dova. So, homolytic cleavage means the shared pair of electron is to be divided equally, and this is to be divided unequally. Okay, if the shared pair of electron divided equally, that is homolytic cleavage. If it is not equally, then that is heterolytic cleavage, right? Achha. In homolytic cleavage, suppose we are taking ethane. If the cleavage takes place, then the shared pair of electron is moving one to each of the bonded atom. Okay. Here, if it is heterolytic cleavage, then the shared pair of electron will move towards one of the bonded atom. So which atom it will move? Towards more electronegative atom. So it is CH3 plus, Cl minus, and if it is lithium, then lithium is electropositive. So pair of electron will move towards carbon. Now student, can you see? In this case, the division of or the distribution of electron takes place equally among two bonded atoms, two carbon atoms. But here it is moving towards one of the bonded atom. So which bonded atom? Towards more electronegative atom. So which is more electronegative? Between carbon and chlorine, chlorine is more electronegative. So carbon will lose electron. So as a result of this, a कौन बनेगा? Carbocation or carbonium बनेगा. And this will make Carbanion. And what are the names of these? These are known as free radicals. If you wish to note down, quickly note down. So we can conclude that as a result of homolytic cleavage, it will make free radical, and as a result of heterolytic cleavage, it forms both carbocation and carbanion. Both carbocation and carbanion. Okay, noted students? If any doubt, then write in the chat box. Next is, what are the reactive intermediates? What are the reactive intermediates? So what do you mean by reactive intermediate? Now the species, reactive intermediate means these are the species which are formed as a result of the reaction from the reactant before the product formation. That means reactive intermediates are formed from the reactant and before the formation of the product. Product banya purvuru that will be formed. Okay, that is the reactive intermediate. And these are highly reactive, as the name indicates, highly reactive. So the reactive अधिक होगा, तार stability कम जीवो, और तार existence is for very short time. So, or in other words, you can say it has transient existence. Are you getting? It has transient existence. Okay, so it is having very short time existence. So what are the names? Then naam kahle electrophile, then nucleophile, carbocation, carbanion, free radical, carbene, nitrogen, then benzene. Okay, so these are the intermediates. That is electrophile, nucleophile, carbocation, carbanion, free radical, carbene, nitrogen, and benzene. So these are the reactive intermediates. Okay. So we'll discuss these one by one. Electrophile, as the name indicates, electron plus philicity. Electron plus philicity, that is attraction towards electron. So if any species has attraction towards the electron, then what will be the charge associated with it? It can have either positive charge or positive charge center. Positive charge or positive charge center. Positive charge means it can be cation, like a CS3 plus, Cl plus, NO2 plus. So these are the electrophiles. And what do you mean by positive charge center? Positive charge center means it is electron deficient species. Then BF3, AlCl3, electron deficient, SO3 भी कही परिवा, electron deficient because it has +6 oxidation state. In SO3, sulfur has +6 oxidation state. So it is highly electron deficient. And the electron deficient that is electrophile. So I hope all of you got this. Achha. So next, electrophile कौन है परिवा? Either cationic है परिवा or the species with positive charge center. Species with positive charge center. Then nucleophile. Nucleophile means nucleus plus philic. Nucleus loving. So nucleus loving hele. So nucleus means positive charge is loving hela. So it must have either negative charge or negative charge center. So negative charge center पहले कौन पूछो? The negative charge center means it can have the lone pair. It can have the lone pair. So negative charge क्या है? Cl minus, Cn minus, OH minus. So these are the anions. NO2 minus. So these are the anions. And negative charge center means a lone pair means H2O, NH3. So these are the nucleophiles. So it can be either negatively charged or molecule with lone pair. Molecule with lone pair. Okay. So nucleophile out hoche ambident nucleophile. Ambident nucleophile. So what is the meaning of the word ambi? Ambi means confusion. Ambi means confusion. If we have any nucleophile, in which the negative charge center can be either with or can reside with either of the atom. Can reside with either of the atom. Like Cn, Nc. So negative charge can reside with carbon or nitrogen. NO2, ONO. Negative charge can reside with nitrogen or oxygen. Okay. SCN, NCS. These are the ambident nucleophile. Means there is ambiguity. In other words, you can say there is an ambiguity in deciding the nucleophilic center. In deciding the nucleophilic center, that means which one will act as the nucleophilic center. There is ambiguity. Ambiguity means answer confusion. Okay. Okay. Up to this clear? Achha. Carbocation. As you know, carbocation is the species in which positive charge is present with the carbon. That is carbocation. So then carbocation, देखिए an example. It can be CH3 plus. If it is CH3 plus, then what will be the shape and hybridization of carbon? Now it is sp2 and trigonal planar. sp2 and trigonal planar. Okay. Then carbanion. Carbanion can be the example we can take CH3 minus. The hybridization is sp3 and this is trigonal pyramidal. sp3 and trigonal pyramidal. All of you got this? Note down quickly. In case any doubt, you can write in the chat box. Then free radicals. CH3 dot or CCl3 dot. Okay, you can take CH3 dot or CCl3 dot. So what will be the hybridization of carbon in CH3 dot and CCl3 dot? Can you write quickly? The hybridization of carbon in CH3 dot and CCl3 dot. Quick. And after solving, write in the chat box. Okay. Okay. Jagdish Prasad Naik. Okay. Wait. What are the legends? I will explain. Okay. If you'll see in case of CS3 dot, CS3 dot, the hybridization is sp2 and it is sp3. Someone has written as a previous slide bond cleavage, that means bond dissociation, bond breaking. Okay, friends, so that is bond cleavage or bond breaking or bond dissociation. So now the hybridization CH3 dot, that is CH3 dot, that is sp2 and CCl3 dot sp3. Now the field orbitals contribute towards the hybridization. So that means CH3 dot in one of the orbital single electron is present. So that will be considered as on-hybrid orbital. Baki jo tinta hybrid orbital raile, that is the field orbital in which one of the electron is contributed by carbon and other one is hydrogen. So which follow tinta orbital raile mane the hybridization will be sp2. But I mean CCl3 dot dekhiba. So the orbital containing single electron, the orbital containing single electron that is belonging to carbon must be considered as the hybrid orbital. Must be considered as the hybrid orbital. Kahinki? So the rule achi the peripheral atom is more electronegative. If the peripheral atom is more electronegative, then the electron belonging to single electron belonging to the orbital will also considered as the hybrid orbital. The single electron belonging to the orbital will also be considered as the hybrid orbital. ताले इठी जो orbital अच्छी पे hybrid orbital लेगला. So in total कितना orbital लेला? 4 लेगला. 4 माने sp3. Now come to carbon हम discuss करिबा. Nitrine. So nitrine is this. This is nitrine. And this is benzene. Carbon we will discuss in the next slide. Okay, written, quickly note kara. Then we'll move to discuss the carbon. आज जतिका में GOC पढ़ते आज रिवाइज करेंगे then तापर हमें next topic को जीवा. Noted? Okay. So we are going to discuss carbon now. Now in carbon, it can be represented as, student, it's my request not to write anything in the chat box. It is going to distract others. Okay. So jota relevant achi or tomar jodi kichi doubt achi, then you can write in the chat box. CH2 double dot. Now carbon has two field orbital, and remaining 2 orbitals are also present. Because carbon is the second period element, in total 4 orbitals are present. So, baki jo 2 electron rahila, how these 2 electrons will be arranged? Now, these 2 electrons can be arranged one here, or it can be arranged this. So, how is it possible? We must follow the Horn's rule in order to arrange the electron. But Horn's rule is applicable only for the ground state, not for the excited state. Okay. So here we are talking about the reactive intermediates. So reactive intermediates are not the species present in the ground state. These are the species present in the excited state. These are the species present in the excited state. Okay, or high energy state. Now, since these are present in the high energy state, then Horn's rule is not applicable. तमें देखो Horn's rule हो कि above principle हो, these are applicable for the species present in the ground state. Then तमें phosphorus रा electron configuration लिखो जाओ 1s to 2s to 2p6 3s to 3p3 in the ground state. So the excited state लिखिबा 3s1 3p3 then 3d1. So that is taking place in excited state. बुझी पारलो? So excited state re, it is not bound to obey above principle or Horn's rule. So it is also the same. Achha. Then what are the name of the species? This is triplet. And this is singlet. Triplet and singlet. Then triplet dekhiba. Why the name is triplet? Now it's based on the value of spin multiplicity, that is 2s plus 1, where s is the sum of individual spins of the electrons. Okay, sum of individual spins of the electrons, modulus. তাহলে ঠিক হো, এটা কোন হবো না 2 আছে, so half plus half, both are same, either clockwise or anti-clockwise, তার mod নেলে 1 হবো, তাহলে 2s plus 1 কে হবো কো, that is 3. এটি কোন হবো না 1 is half, another must be minus half, so 0, 2s plus 1 কোন হইবো 1 হইবো. বুঝ পারলো? From here we got the name triplet and singlet. It based on the values of spin multiplicity. It based on the values of spin multiplicity. Okay, so these are the reactive intermediates. Student, quickly note down the one note not karcho, quickly note kar diyo, then we'll move to the next topic. If any doubt, then only write in the chat box. Written? Okay, note down, note down. Then electron displacement methods. Electron displacement method. That means, as you know, in carbon, how many atoms can be bonded? So it can be up to thousands of atoms in case of the polymers. So since all the atoms are directly bonded with each other, then what about the displacement of the electron? Whether the displacement of electron will be between 2 atoms, or it can be propagated to more than 2 atoms. Okay. it can be whether it can be propagated to more than 2 atoms or it will be restricted between 2 atoms. Discuss kariba. Okay. So what are the electron dispersion methods? There are 4 methods. That is inductive effect, then resonance or mesomeric effect, then hyperconjugation, then electromeric effect. Electromeric effect. Okay. So these are the methods known as the electron dispersion methods. So we are going to discuss them one by one. Aryan, this is the basic principles of organic chemistry. Before going to discuss the class 12 syllabus, हमें जोड़ा 11th already किसी topic हम discuss करी थी, किसी topic discuss ही नहीं थी. So we are going to discuss this. तक तमें general principles of organic chemistry और GOC कही परिबो general organic chemistry. Okay. Up to this clear? So now we are going to discuss first the inductive effect. That's another thing. Among these methods, first 3 are permanent effect and the last one is temporary. First 3 are permanent and the last one is temporary. Note down. Permanent means it cannot be changed. Okay. Permanent means it cannot be changed. That is visible na hoichi mu tumko outre korchi. These 3 are permanent and this is temporary. Permanent effect and temporary effect. Okay. So first, let us discuss the first one, that is inductive effect. First one, that is inductive effect. Inductive effect, as the name indicates, inductive, induce. As the name indicates, inductive means induced. Okay. How the charge is induced? So then देखिबा. Suppose butane, I have not written hydrogen, but hydrogen atoms are there. Suppose in butane, all the 4 carbon atoms are identical. So there will be no shifting of electron, or there will be no unequal shifting of electron, or the electrons is arranged uniformly throughout. The electrons are arranged uniformly throughout. Now this is there is no inductive effect present here. You can write one more. But when you are attaching one carbon, one different atom, let it be chlorine, let it be lithium, then what will happen now? Chlorine is more electronegative. So it is going to have the partial negative charge. As a result, carbon partial positive charge. Lithium partial positive charge and carbon partial negative charge. Now the distribution of electron becomes unequal. Okay. So in this case, it is not the uniform distribution, rather this is the non-uniform distribution. Once the partial positive charge or negative charges are present, then will it be confined to this atom or it will be migrated to other atom? It will be migrated to other atom. How? Now this will be double delta plus, and this is triple delta plus. It is double delta minus and it is triple delta minus. So double delta means it is gradually decreasing. Double delta means it is gradually decreasing. ता माने डायरेक्टली बॉन्डेड एटम पाखरे जति की पार्शियल पॉजिटिव चार्ज रहइबो तापर से ग्रेजुअली डिक्रीज हेगी जाउची. डायरेक्टली बॉन्डेड एटम पाखरे पार्शियल नेगेटिव चार्ज जति की रहइबो से ग्रेजुअली डिक्रीज हेगी जाउची. जो डिक्रीज होउची that is induced. So the name is inductive effect. Okay. So types of inductive effects. It is of two types. One is plus I, another is minus I. Plus I and minus I. Positive inductive effect and negative inductive effect. अच्छा. ताले positive negative माने किसी एक reference atom थी वो. So which is the reference atom? The hydrogen is considered as the reference atom. So hydrogen का मैं reference atom नहीं की. तापर देखिए यदि positive charge develop होची कोचरे carbon रे. So obviously जो atom अच्छी तापर के negative charge थी वो. So एटी lithium पाखरे positive charge अच्छी carbon पाखरे negative charge अच्छी partial negative charge अच्छी. तो ताले देखो ये जो atom अच्छी chlorine it is associated with partial negative charge. So that is known as minus I group. Is associated with partial positive charge. So it is known as plus I group. It is known as plus I. Which value? Well, hydrogen zero inductive effect. It is neither plus I nor minus I. Hydrogen respect रे जे electron release करिवो carbon को. Hydrogen respect रे जे carbon को electron release करिवो. That is plus I. And hydrogen respect रे जे carbon रो electron withdraw करिवो. That is minus. Okay, that is minus I. It is clear, students. Now आमे देखिबा it is minus I and plus I. हम देखिले plus I means which releases electron to the carbon chain and minus I means which withdraws electron from the carbon chain. Which withdraws electron from the carbon chain. So what are the examples of plus I group? The examples of plus I group are alkyl group. Okay, it can be alkyl group. O minus, NH minus. Oxygen is more electronegative, so it should be minus I. How can it will be positive inductive effect, or NH minus is also showing plus I effect? How come it is? Alkyl oxygen is second period element, so it has only the cells up to the second cell. That is, second cell means there is no vacant d orbital. So the negative charge it cannot be dispersed by any other means. Negative charge negative charge density. So in order to delocalize the negative charge, effect nahi. In order to delocalize the negative charge, there is no effect. Now it has the tendency to release electron. So the electron releasing tendency is plus I effect. O minus is plus I and NH minus is also plus I. All of you got this? O minus plus I and NH minus also plus I. Okay. Acha. O minus NH minus ro plus I power jo habo, that is even more than the alkyl group. That is even more than the alkyl group. Then देखिए गले सबुठार अधिक कोन हबो अंक भितरे ना plus I power अधिक हबो this then this. अच्छा alkyl group रे suppose हम पाखे अछि CH3 CH5 C3H7. So which has more plus I power? A tinda bhitar which has more plus I power. Rather ABC tinda naba. So plus I power is C greater than B greater than A. C greater than B greater than A. Okay. Acha. Next. तापर कोन रहइबो? Suppose हम पाखे अछि primary, secondary, tertiary. Suppose C3H7, that is normal. Then this is another, and primary, secondary, tertiary. So let it be. It is 1 degree. This is 2 degree. This is 3 degree. So what is the power of plus I group? Now it is tertiary greater than secondary greater than primary. First, now with the increase in number of carbon atoms, plus I power increases. Again repeating, with the increase in plus I power, with the increase in number of carbon atoms, plus I power increases. Second, with the increase in degree of carbon, the plus I power also increases. So it is tertiary greater than secondary greater than primary. Again repeating, tertiary greater than secondary greater than primary. Okay. So up to this clear? Now come to minus I. Minus I kona? Now baki ja rahe so minus I rahe. Halogens, then OH, NH2, carboxylic acid, then you can say the derivatives of carboxylic acid, aldehyde, ketone, NO2, SO3H. So all these are showing minus effect. All these are showing minus effect. Okay, students. अच्छा. So आपको compare करिया पे जब देखिबो जेम हम कहले जदि minus charge थिबो that will be strong plus I. Similarly जदि plus charge थिबो NH3 plus or NR3 plus. If the plus charge thibo, this will show strong minus effect. This will show strong minus effect. Okay. सीधा कथा ला जहाँ पे यदि negative charge अच्छी तार electron releasing power अधिक रहेगा, so strong plus I. जहाँ positive charge अच्छी electron withdrawing power अधिक रहेगा, so strong minus I. Strong minus I. Up to this clear? Then all of you, up to this clear? Okay. Next देखिबा. So this is the type of plus I and minus I groups. अच्छा. Next is जो तुम compare करिया दिया होगा, तो compare करिया दिया ले तबे लिख परियो. Suppose ଗୋଟେ question ଅଛି, fluorine. 1 minute. CBA means I don't know why you're writing so many things, sir. CBA means C. What is C? That is propyl, then ethyl, then methyl. Okay, so this is the power of plus I. That is, propyl is greater than ethyl, greater than methyl. So the one note not quickly note kar diyo. Take 1 minute, quickly note down. Writing. NR3, that is tri. R means alkyl. Trialkyl ammonium ion. Trialkyl ammonium ion. So the one note not student note kar diyo quick. Take 1 minute. Okay, completed. Okay. Next. Suppose you have chlorine, chlorine, bromine and iodine, chlorine, OH, NH2. Chlorine, OH, NH2. Okay. So what will be the order of minus I? What will be the order of minus I? Quick note down. Then I'm going to discuss. Minus I means it is the shifting of sigma bonded electron towards the more electronegative element. That is what the meaning of minus I effect. So written here, the answer is okay. Is it visible? Or I have to use some dark color. This. So fluorine greater than chlorine greater than bromine, then iodine, and next one is fluorine, OH, then NH2. Simply it is the order of electronegativity of the bonded atoms. Okay. Now, inductive effect is clear. What are the applications of inductive effect? What are the applications of inductive effect? So applications are, first, it is you can say bond polarity. First application is bond polarity. Second is the stability of reactive intermediates. Third is reactivity of এটা তোমার halo alkane haloarine chapter পড়িবা reactivity of halo alkane, then acidic strength of alcohol, then acidic strength of carboxylic acid, then basic strength of amine. Basic strength of amine. Then quickly note down. खबर में one by one तो discuss करेंगे. Note down quickly. First is bond polarity, second is stability of reactive intermediates, third is reactivity of haloalkane, fourth is acidic strength of alcohol, then acidic strength of carboxylic acid, then basic strength of amine. Okay, basic strength of amine. So these are the applications. These are the applications. Okay, now we are going to discuss one by one. Now see, if you move to the previous slide, in this case, you can see in this case, carbon and chlorine. Before attachment of the chlorine, there was no charge dissimilarity among the carbon atoms. All the carbon atoms having uniform distribution of electron. তাহলে সেটি না কিছু partial positive charge ছিল না কিছু partial negative charge ছিল। But once the chlorine is attached, so chlorine acquires partial negative charge, carbon partial positive charge. তাহলে এটা কোন হলো partial positive negative charges আসলে। Similarly second case রে lithium and carbon, lithium partial positive and carbon partial negative. So the partial positive negative charges আসুଛି। So due to this the bond becomes polar. তাহলে compound রে ଗୋଟେ ଯଦି polar bond ରହିଲା ତ compound is polar. And the polarity asuchi due to the presence of either plus effect or the minus effect. The polarity is developed due to the presence of plus effect or minus effect. Okay, it is clear. So first one is bond polarity. Second, stability of reactive intermediate. So reactive intermediate, I mean, discuss we will basically see carbocation, carbanion, and free radical. So the carbocation nature called carbon cation, that is electron deficient. Carbon anion, that means electron rich. Our free radical, that is also electron deficient. The free radical, carbon how many electrons are there? 7 electrons are there. The 7 electron that is less than 8 electron. That less than 8 electron that is electron deficient. The 8 electron electron precise. And more than 8 electron is electron rich. Okay. So carbon cation or carbocation, that is electron deficient. Electron deficient species can be stabilized over electron release. So which are the releasing groups? Electron releasing group, that is plus I. So in other words, you can say plus I group increases stability of electron deficient. It is carbonium or free radical. Minus I group decreases the stability of electron deficient species. Similarly, minus I group increases the stability of electron rich species. So electron rich species ki asbo? Carbanion. Okay, and decreases the stability of electron plus I group decreases the stability of electron rich species. Plus I group increase karibo stability of electron deficient and minus I group increase karibo stability of electron rich. Okay, tale gote question fatafor lekho an example dekhiba. Arrange the stability of these reactive intermediates. Also write down the stability order of so these are the 3 questions. So you have to arrange the stability order of these species. Quick. Take 2 minutes. Quick. When writing, so after writing, then write your answer in the chat box. Completed? Write your answer in the chat box. In the order, decreasing order, lekho. 1, 2, 3, 4. Decreasing order. Okay, good. Other students? Now, the answer for the first question, decreasing order, 4, 3, 2, 1, and it is 1, 2, 3, 4. Second and third one is 3, 2, 1, 4. Compare with your answer. जो मन आंसर मिली write in the chat box. Okay. Acha. Now, I think first, second question है किसी difficulty ना थी वो. Deeptimay good. Arpita, Om Prakash good. So first, second रे किसी difficulty ना थी वो. Because it is, I'm कोई पर carbocation रो stability कौन हो? ना carbocation stability हला tertiary greater than secondary greater than carbocation. Tertiary, secondary, primary, then methyl. And Carbanion stability is methyl, primary, secondary, and tertiary. Okay, Carbanion stability is just reverse. Now, in the last one, NO2. In the last one, it is NO2. NO2 means that is minus I. And it is minus I. It is minus I. And it is plus I. So obviously, that is plus I will be the least stable. बाकी तीनटा देखिए minus I भितर NO2 makes more minus I than fluorine and chlorine. So NO2 is first one. तापर देखिए between fluorine and chlorine. Between fluorine chlorine, minus I power of fluorine is greater than chlorine. Again repeating, minus I power of fluorine is greater than chlorine. Okay, so minus I fluorine रो अधिक होगा. So fluorine should be more stable. माने one should be more stability, should have more stability than two. But answer लिखा है chlorine is more stable than one. The reason कौन? No, it is back bonding. बुझिपारा student? The reason is back bonding. In Cl, back bonding is possible as it contains vacant orbital, whereas in fluorine there is no vacant orbital, so back bonding is not possible. So in fluorine, back bonding is not possible. Okay, students. अच्छा. So quickly note down. एमि देखिबा दी एटा NO2 रे तमके NO2 रे तो back bonding हबनी, NO2 रे resonance हबो. So NO2 makes minus R, and it is a resonance discuss करिबा. It is back bond, and ये तो minus I रहिला. Note down. Okay. So now we are going to discuss the next application कौन थिला? Reactivity of haloalkane and haloarine. Haloalkane, haloarine पछे discuss करियो resonance order रे. So if you'll see these 4 haloalkanes. So the question will be asked, what is the order of reactivity of these haloalkanes? So मैं first देखिए पड़िबो the reactivity order decide कला को which is the reactive side. And the reactive side को position रे reaction होची. That is position रे reaction होची between the bond carbon and halogen. So it makes carbocation and halide ion. In other cases also the same. It will make the tertiary carbocation and halide ion. So we know more the stability of the carbocation. Again repeating, more the stability of the carbocation, it can be easily formed. If it is easily formed, then that is more reactivity of the haloalkane. And detail haloalkane chapter also discuss kariba. Kalkile etige note kar paribo. Now more the stability of carbocation, more is the reactivity of haloalkane. More is the reactivity of haloalkane. Okay. Next, acidic strength of carboxylic acid. Acidic strength of carboxylic acid and alcohol. So यदि alcohol देखियो, it can release H plus to form alkoxide ion. It can release H plus to form alkoxide ion. So this alkoxide ion, that is anion. So anion को anion stability कहाँ पर depend करियो? Now this alkyl group. Okay, this alkyl group. हमें कहीं पर यह more the plus effect. More the plus effect. More is the lesser is the stability of alkoxide ion. A plus effect is electron releasing. Our alkoxide ion already negative charge अछि. Negative charge थिले ताले plus I power अधिक रहेबो. ताले कोन हबो तार negative charge रो stability और alkoxide ion रो stability कमी दिबो. Same thing happens with the case of carboxylic acid. जब हम carboxylic acid देखिबा, more the plus I power of the alkyl group, lesser is the stability of carboxylate ion, and hence more is lesser is the acid strength, and hence lesser is the acid strength. ताले हमें compare करिबा alcohol, ethanol, methanol, ethanol, propanol. Okay. So एक question है थोड़ा NEET रे पचार थिला. You can see. Okay. So what is the order of acid strength of these species? I'll quickly note karo. So let's say this is 1, 2, 3. So what is the answer? The first case, it is 1 greater than 2 greater than 3. Second case, it is 1 greater than 2 greater than 3. Okay. 1 greater than 2 greater than 3. I think all of you got the answer. Which students? Now more the plus I power, lesser is the acid strength of carboxylic acid or alcohol. Lesser is the acid strength of carboxylic acid and alcohol. And note more the plus I power, lesser is the acid strength of carboxylic acid or alcohol. Okay, all of you got this. Next is basic strength of amine. We are considering the amine. So amines are bases. Which type of bases? It can be Lewis or Bronsted base. Kahinki? Now in amine, nitrogen contains lone pair, so it can donate lone pair. जे donate करछो lone pair ताको कौन कहजिवो Lewis base और जे H plus accept करितो proton accept करितो that is also Lewis base. So amine sorry Bronsted base. So that means amines can be Lewis base or Bronsted base. Both are same. एक case रे देखियो ammonia case रे जहाँ पाके lone pair available जेते अधिक थिबो सेते easily से donate करि परिबो. So stronger Lewis base. जहाँ पाके lone pair जेते easily available थिबो सेते easily H plus accept करिवो. So stronger base. So stronger base. So ताले lone pair और availability केमिति increase हबो ना due to the presence of plus I group. Due to the presence of plus I group. ताले more the plus I power, more is the electron density around nitrogen. More the electron density around nitrogen, more is the tendency to donate electron, and hence more is the basic strength. So हम पाखे जदि रहिबो ammonia रहिला primary amine, secondary amine, and tertiary amine. So what will be the order of basic strength of these? This is the order of basic strength. Tertiary greater than secondary, greater than primary, greater than ammonia, greater than ammonia. Note down. I hope all of you got this. So with this, the applications of inductive effect over. Okay, with this, the applications of inductive effect over. Resonance or mesomeric effect. So note kar student. Can you write the resonating structure of the following species? Take just 2 minutes and write down the resonating structure of these species. देखिवा के जनकर माने अछि. Take 2 minutes. I hope all of you are trying. All of you are trying. I hope all of you tried. Now, it is lone pair in conjugation with pi bond. So then भूल जाइए, don't be panic. मैं discuss करिबा starting रो. and here pi bond in conjugation with pi bond. Okay, here in case of chlorobenzene, chlorine contains lone pair. So lone pair in conjugation with pi bond. Next, quickly note down. Student, can you raise your hand? I mean, if you did it correctly. Shruti Satpathy, okay, good. Other students? Deeptimai, okay. Om Prakash, Maheshwar, Dilleswari, okay, very good. So the man student, quickly note down. Om Prakash, good. Muktimai, good. And the other students also, very good. Suchishmita Oja. Okay. Then note करचा. Okay, very good. Now the question is, what is resonance? Now it is the phenomenon by which more than one structure can be drawn. The phenomenon by which more than one structure can be drawn. What is the need of writing more than one structure? Because single structure is insufficient. Are you getting? Single structure is insufficient in explaining the properties. So in order to know all the properties of the compound, we have to draw more than one structure. So these structures are known as the resonating structure or canonical structure or contributing structure. Resonating, canonical or contributing structure. And just the resonating structure देखुचे, all are hypothetical structures. All the resonating structures are hypothetical structures without any real existence. यदि real existence था गोटे molecule भी गोटे ion रो गोटे ही structure रहिबो. So real existence नाही, सेथिबे हमको हेल्प नवा पड़छि more than one structure. जदि हम कहिबा ना जे तुमको मो in general answer आर एक्सप्लेन करे जे तुमको गोटे एग्जैक्ट आंसर जणा नाही ताले तुम आंसर गोल गोल बुलाओ. yes or no? तामाने को it can be the answer, एटा भी आंसर हे पारे, एटा भी आंसर हे पारे. तामे देखला कोन तुम एग्जैक्ट आंसर जणा नाही. So सब आंसर जे मिसै दो तुम जति के सब चारि पांचटा आंसर कहइबो सब मिसै दो फाइनली कोन हबो? द आंसर इज within these five answers. तामाने सब आंसर टिके 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 कंट्रीब्यूट करले कोन हबो? फाइनल आंसर मिल जाओ. सिमिलरली हमें जति के रेजोनेटिव स्ट्रक्चर लिखुचे जति जेमति हमें एठी एते रेजोनेटिव स्ट्रक्चर 5 लिखिले तो सब स्ट्रक्चर किछि किछि इंफॉर्मेशन हमते मिल जिवो ताले ओवरऑल इंफॉर्मेशन कोन हबो? कंप्लीट इंफॉर्मेशन हे जिवो. So the thing is, resonative structures are hypothetical structures without having the real existence. Without having the real existence, that is resonative structure. तापर देखिबा रेजोनेंस रे कौन कौन कंडीशंस अछि लिखिला बेलकु रेजोनेटिव स्ट्रक्चर लिखिला सब स्ट्रक्चर रेजोनेटिव स्ट्रक्चर लिख परिबानी कंडीशन कौन द फर्स्ट होची इन रेजोनेटिव स्ट्रक्चर्स द पोजीशन ऑफ एटम्स शुड रिमेन द सेम एटम रो पोजीशन की चेंज होबा एटम पोजीशन सब बेले सेम रहइबो रेजोनेटिव स्ट्रक्चर एटम रो पोजीशन सब बेले सेम रहइबो फर्स्ट पॉइंट क्लियर सेकंड it is only the shifting of loosely bonded electron कौन आसपारे pi bond हे परियो lone pair हे परियो नेगेटिव चार्ज it cannot be the sigma bond केबे भी रेजोनेंस में पार्टिसिपेट करेनी नेक्स्ट आउ कोन हबो रेजोनेंस रे ना इन रेजोनेंस it can be the it has to be the atoms which are the part of resonance must be planar or nearly planar then देखो floor is planar the floor बेले बेले कोन है गोटे rough surface जेतो that is exactly not planar but that is nearly planar so resonance कोन है दरकार planar है दरकार और nearly planar है दरकार in order to transfer the electron shifting सेतोल हबो जेतोले planarity थिबो कारण दीटा अलग अलग प्लेन रे एटम रहिले जो एनर्जी चेंजेस हुए एनर्जी कॉन्सिक्वेंस है दैट इज वेरी हाई जोटा कि इजीली हुए आउ कोन कंडीशन अछि रेजोनेंस रे हला द एनर्जी ऑफ ऑल द रेजोनेटिंग स्ट्रक्चर्स मस्ट बी सिमिलर और सम आर आइडेंटिकल सिमिलर रहितो और आइडेंटिकल रहितो ओके सो दीज आर द कंडीशंस आउ रेजोनेंस आउ रे कंडीशन भी अछि the resonative structure should obey octet rule तामन जेम जेम जानछे नाइट्रोजन रे सेकंड पीरियड एलिमेंट नाइट्रोजन रो आउटरमोस्ट सेल रे 8 इलेक्ट्रॉन अधिक एकोमोडेट हे परिबनी सो यदि 8 रो अधिक इलेक्ट्रॉन आसुची so that is not the resonative structure okay so student these are the conditions we have to take care while drawing the resonative structures तापर देखिबा टाइप्स ऑफ जेम टाइप्स ऑफ इंडक्टिव पेयर देखथिले एटा देखिबा टाइप्स ऑफ रेजोनेटिव स्ट्रक्चर्स रेजोनेंस टाइप्स ऑफ रेजोनेंस इफेक्ट और मेजोमेरिक इफेक्ट तापरे आउ गोटे टॉपिक अछि स्टेबिलिटी ऑर्डर ऑफ रेजोनेटिव स्ट्रक्चर्स आउ रहबे तापरे एप्लीकेशंस ऑफ रेजोनेंस आकमे विल डिस्कस इट आफ्टर द ब्रेक ओके सो टेक द ब्रेक ऑफ 15 minutes then we'll rejoin again to discuss the topics okay